My name is Pamela Hill. I'm a developer advocate at JetBrains for Kotlin. So I'd like to begin by asking you a question. What brings you to this talk today? Perhaps you've heard about Kotlin Multiplatform before, and what you heard made you super curious to find out more, like this llama. Or perhaps you've given Kotlin Multiplatform a try, but you have some questions and you'd like to take your knowledge to the next level. Or are you just vibing here until the end of the conference? Yes, it happens to all of us. Whatever your reason is for attending this talk is for you. Thank you for attending my talk. We'll be looking at some basics, yes, but for those more experienced Kotlin Multiplatform developers in the audience, we'll also be taking some very nice deep dives. So for those just vibing, I'll try to keep you awake until the coffee break. You are allowed to laugh. So today, we'll be going on a little adventure, exploring the Kotlin Multiplatform ecosystem. And my hope is that I can get you so excited about Kotlin Multiplatform that you'll be excited and that you'll want to share what you've learned with your colleagues and your communities. So my topics today are kind of ordinary topics. Most apps have some form of networking, some form of persistence, and usually these need to be done asynchronously. And because we are good, upstanding folks, our apps also use some form of dependency injection. And of course, if it's not just a play or toy project, eventually we'd like to move to production. But don't let these broad topics fool you. So the Kotlin Multiplatform ecosystem is going to impress you with its ability to do these things super well. So let's get started with networking with one of my favorite multi-platform libraries, Ktor. Perhaps you've heard of Ktor before, but in a server context. But it's actually more than that. So it also includes a powerful multi-platform client that is perfect for using in your Kotlin multi-platform apps. So it's not just a highly configurable REST client, it can also do WebSockets and protobufs as well. When you set up your Ktor client, you have to configure it with a platform-specific engine that will process your network requests. There are different engines for Android and iOS, and you configure what Ktor should use in your Gradle build files. You can sort of further configure some common functionality by adding plugins like content negotiation and serialization, security, WebSockets, which is a little bit of a spoiler, and so on. So our first demo app is from the JetBrains site. It's a tutorial that you can go and do if you haven't done Kotlin Multiplatform at all before. And it will guide you on how to create a Kotlin Multiplatform app using the libraries Ktor and SQLDelight. So the app gets data from the SpaceX rocket launch API using Ktor, and it shows it on the screen, like so. And then it uses also SQLDelight, which to do some local caching, but we're not going to focus on that today. So before we start using Ktor, we actually need to set up a way for the data from the API to be deserialized into Kotlin. We do this with the help of a library from JetBrains as well, called Kotlin serialization. The first thing we need to do is really look at the structure of the data coming back from the API and create a similar data structure in Kotlin. Then to get Kotlin serialization to correctly deserialize, we need to annotate each class of the data structure with @serializable. If you want to rename a JSON field to make it something closer to more idiomatic Kotlin, you can use the @serialName annotation. We also need to set up this plugin in our Gradle build files. Next, we need to create a class in our shared code for accessing the API from the rest of the application. So this class has a HTTP client property, and we're going to look now at how we're going to set that up. So Ktor has a really nice client DSL to create the HTTP client and consume it and to configure it to consume JSON or whatever. So the content negotiation Ktor plugin is set up here, and then we are configuring it to use Kotlin serialization to convert the JSON to Kotlin objects. Now, Ktor actually supports different formats, not just JSON. So next, we need to create a function that the rest of our app is going to use to get all the rocket launch data, and we're going to call it get all launches. To get all those launches, we use the HTTP client's get function. Sorry, my clicker stopped working. Sorry. Okay. The get function, and then once we've received the response, we retrieve the body. And then Kotlin serialization is going to return a list of rocket launch objects to us. Now, I would like to ask, how many of you are Android developers? Just raise your hand. A lot. iOS developers? A few, you're welcome. Okay, so a question I often get asked, especially by Android developers, is if there is a multi-platform library similar to Retrofit that they can use. Apparently, it's a super, super popular library. I used to use it too when I was an Android developer. So the answer is yes, there's a library called Ktor. Let's see how we can use this library to make our code just much nicer and closer to what we are used to. So first, we need to update our SpaceX API class. It's now an interface. And we're going to have an annotated function declaration on it. So previously, we were using HTTP get method, so we annotated with @get, and launches is the path. And now we need to introduce a class called SpaceX SDK. Now this is what the rest of the app is going to use to make calls on the API. So we're kind of putting SpaceX SDK in front of SpaceX API. This class is then going to set up the Ktor sort of client, the API, and then provide some functions through which we can call the API. So first, we need to set up Ktor with another DSL. So we give it the base URL, the HTTP client configuration, which is exactly the same as in the REST section, and call response converter. It also supports flows. To create the API that you're going to call, you call ktor.create with your interface, and Ktor will do the rest. And then it's time to provide a function through which our clients can call. So it's we're basically just creating a get launches client that's going to call through to the API. So I think this is a really nice approach because you're separating out how you're making your call versus what you're actually calling. And I think that if your API grows, which APIs always do, and you get more endpoints, and things become more complex, it's going to still stay maintainable. When I was still doing Android development and I had to debug like endpoint calls, I would always look up the details in the API section, so in the retrofit section or the Ktor section, and look up those call details, and then I would put my breakpoints on the SDK side, the actual function calls. Let's have a look at WebSockets next. How many of you attended Svetlana and Anton's talk a little bit earlier? Okay, a few. So this demo app might look somewhat familiar because I totally stole a little bit of their code. Don't tell anyone. Okay, if not, they developed this chat app that worked with Ktor WebSockets to illustrate some key Kotlin X libraries. So it's basically what you expect from a chat app. You can send a text message, it will go via the server, and it will be a received message on your friend's chat app. Then it will also show that your friend is typing, and that message will go through to the server, and you can aimlessly wait for your friend to stop typing and send the stupid message. We've all been in that situation where you're just waiting endlessly for that message. Okay, so let's have a look at how this would actually be implemented with Ktor. So first we need to configure the HTTP client with the WebSocket plugin. So it's really important to also have a content converter. For example, there will be a JSON content converter in this case. And then we have to open the session, giving the method, so this would usually be like a get, a hostname and port, and a WebSocket path. And now we have a couple of options. So first we can send events to our friend over the WebSocket via the server using the send serialized function. Or we also want to hear from our friend, so we can do that by observing incoming events on a flow. So you can deserialize events with that same converter as well. And then finally, when it's time to end the chat, we need to close the session. So the last thing I want to show you about Ktor is protobufs, or protocol buffers. Perhaps you're using it at your company, or you've heard about it. So protobufs are Google's language-neutral, platform-neutral way of serializing data, and it is more efficient than JSON. So the structure of your protocol buffers need to be defined in a .proto file, and it has a very specific structure of how your data is going to look. So specific, it's actually a little bit annoying. So to use Ktor, to use it with Ktor client, you can use Square's wire plugin to take that proto file and generate your Kotlin classes with it. Then you add protobuf as a serializer in your content negotiation plugin, and then you're done. It's really as simple as that. It's really quick and simple to set up. So something interesting to note that I found out is that there's experimental support for generating from your Kotlin classes that you can annotate with some proto annotations. You can actually generate your proto definitions, which kind of makes sense if you're starting Android first, then going to proto, and then maybe integrating with the rest of your app. So a key sort of use case of where I've used protobufs before is a previous company was working. We had a Go backend, and we had a Kotlin Android application, and then a Swift iOS application. And we could share the proto files amongst each other, and because Wire actually supports multiple languages, we could all use Wire to have the same classes, but in our specific languages. It's pretty cool. So persistence. Hopefully your persistence is more persistent than the USB sticks that sometimes get lost. So persistence is a broad topic, so I'm just going to give a little taster of each library that we'll be covering today. We'll be looking at everything from simple key value pair, storage to databases that sync with the cloud and all kinds of other solutions. So multi-platform settings from Russell Wolf. Russell, if you're here, just give a wave. But it is exactly what you need if you want to store key value pairs in a platform-specific way from your shared code. So for Android, you're going to be using shared prefs, and for iOS, you're going to be using NS user defaults. What I really like about this library is the way that it allows you to write more idiomatic Kotlin code. For example, the way that it handles nullability is a lot less Java-y than shared preferences, for example. There is experimental support for coroutines and flows that allows you to sort of, where the platform allows, even allows you to observe the settings as a flow, but you can also use coroutines to put or set your settings. And what I really like about this is that it also has experimental support for iOS keychains, which if you have to integrate with a keychain is really awesome. So the key interface for multi-platform settings is called settings, which you code to for getting and setting your key value pairs in storage. Now the typical way that you're going to get your settings is by wrapping it in a class from your library, and that class will delegate to a platform-specific implementation. You then provide it to your shared code via dependency injection, and what a coincidence, we're going to be looking at dependency injection later. So on Android, you could code the following in your Android main to provide to a dependency injection manager. So You create a default shared preferences. It can be any shared preferences, but like for example here, we're just getting the default. And then you wrap it in the shared preferences settings from the library. And it will always delegate calls to that shared preferences that you provided. On iOS, similar thing, you're just using user defaults.standard, which is kind of like the default, and then using NSUser default settings to delegate calls to your user defaults. To use multi-platform settings from common main, you're going to code to the settings interface. It looks a lot like shared prefs, but with a few differences. Like for example here, it's going to handle a nullability a lot better because here getString won't return a null, versus here it could possibly return a null. So I'd like to mention that the multi-platform version of Jetpack Data Store from our friends at Google is now an alpha. So this is also a key value pair solution that you can consider. So SQLDelight from the lovely folks at Square is a plugin and library. And it is not a database, but it generates type-safe Kotlin APIs for you from your SQL statements at compile time. So it will verify your schema, it will verify your statements, and it's going to verify your migrations. There's also an IDE plugin that will help you to write correct SQL and also edit your SQL by providing like auto-completion and refactoring. So in the multi-platform scenario, SQLDelight will use SQLite, which is also multi-platform. But there are some platform differences on how you access SQLite. So SQLDelight provides different drivers that you have to use from those different platforms, and you can configure that in your Gradle files. So I'm not going to show you the details of how exactly to set up SQLDelight, because they have really nice documentation to show you how to do that. I just want to highlight one or two little things. So the first thing I want to show you is this .sq file. And that SQLDelight will use to create your Kotlin API from. So each statement is labeled, like for example here, where we label our select statement with select all launchers. And we're going to use this label in the next couple of slides. So the rest is just a regular SQLite flavored SQL. So when our app needs to get all the launches from the database, we call the function getAllLaunches in the database helper class. And it is going to use this property that is generated for us by SQLDelight to access all the queries that we've labeled in the previous step. And this will actually we'll use this generated property to get that label that we had before, and we're going to run our select statement like that. So next, Realm is an open source database from the folks at MongoDB. So it is an object-oriented database. So this has a couple of benefits. So you don't have those ugly mappings between the database and your Kotlin code. So you don't have things like ORMs or object relational mappings or DAOs, data access objects. Your code is therefore also much simpler because you're going to there's more similarities between the code in your database and the code in the objects in your database and the objects in your code. So your complex queries are also faster. What's also nice about Realm is the way that it allows you to write more idiomatic Kotlin, and it supports coroutines and flows for us for observing the database and also for setting some stuff. It supports encryption with a key. So you are able to, when you create your database, you provide it with a key and it will encrypt the whole database. And then you will also be able to, when you open the database, you just have to provide the key and unlock the database, basically. But what I really, really like about Realm is this. So it will handle device syncing for you. And this is using their alert, like paid for a product called Device Sync that works with the server-side MongoDB Atlas database for your app. So you can have a Realm database for your phones, your tablets, your desktops, and so on. And it, like device sync, will automatically sync with your cloud-based database and the rest of your Realm databases for you automatically. So Realm has this offline-first approach. So when you are offline, you can use the app as best you can without networking, but when your connectivity is restored, everything is synced in the background for you. It also has automatic conflict resolution, which will help you to best resolve the conflicts in a multi-device context. So the code changes actually needed to go from Realm as just a local object-oriented database to a cloud-based solution is actually impressively small. We had a webinar recently with somebody from MongoDB, and they just demonstrated how little code was actually needed for this. It was actually very, very cool. So our last foray into persistence is with a tiny little library with a big heart that you might want to look at if you want to store an object in a file. It's called Ktor by Usuru Rayapaksa. Usuru, if you're here, I'm so sorry that I butchered your name. I roll the letter R like a South African farmer because I'm South African. But anyway. Okay, back to Ktor. You need to give Ktor a platform-specific file, a file path that you somehow have to calculate, but the documentation is so complete that it actually helps you to do that. So under the hood, Ktor uses coroutines, Kotlin serialization, and that it will use that because you're annotating your object or your classes or objects with annotations, and then it also uses OKIO for actually doing the file reading and writing. It also provides read-write locks and in-memory caching. And what I really like and what I'm really seeing here is that, this library is complex and interesting, but it's standing on the shoulders of giants. And I hope that we'll start seeing more and more libraries from the community that adds value, but isn't too hectic to write. So in the next two sections, I want to look at concurrency with coroutines and flows. So coroutines and suspend functions have been covered extensively at the previous Kotlin Constant online. So I sort of expect that you know what they are. So what I want to cover in this section is really more about how to consume them in a Kotlin multi-platform app. I'm going to touch very lightly on Android because it's more complex, and more extensively on iOS because it's more complex than iOS. So just a reminder of our demo app that we looked at in the networking section. Of course, to get that data on the screen, we have to call the web service in a way that doesn't block the threads. So the SDK.getLaunches function was marked as suspend. So if you are consuming this function from on Android from Compose, you would basically wrap your suspend function call in a launched effect, side effect. It's a Compose side effect wrapper. And it will, when you actually get your data back, so there's the launched effect, and when you get your data back, it's going to cause a recomposition of the pull to refresh rocket launches composable, which is a pull to refresh control and a lazy column list of rocket launch composables. So on iOS, suspending functions aren't a thing. There isn't a Swift UI, Swift or Objective-C concept like suspending functions. So they're represented in the Objective-C headers as completion handlers or callbacks. On the iOS app, we have this published variable, it's an iOS concept, in our view model called launches. And it's going to be displayed on the screen using Swift UI. It has three states, so loading and result and error. So loading is just going to show the spinny, result will show that full table, and error will just show an error message. So ideally, you would get some data in launches, and then you would set this published variable to something that's wrapping the result in a result state. If you get an error, we will set that published variable to something that is wrapped in wrapping an error message in an error state. So this approach has a number of disadvantages. And firstly, if there is multiple suspending functions, this can quickly descend into callback hell. So it's not really readable, especially if you start nesting things. We're also not really supporting the cancellation of asynchronous operations. Instead, we were actually waiting either for a timeout or the results to come back. And this is really bad use of limited system resources. So I want to go through two approaches to improve this. So the first one is where we have this async await mechanism that is part of Swift 5.5 for iOS 13 onward. And we can also use this mechanism in our iOS code. So first, our view model must be marked as @main_actor, which means that the tasks in this view model will be run on the main thread, because calling Kotlin suspend functions on iOS is currently only supported on the main thread. Then we have to wrap our code in a task that supports concurrency. And then we use the await part of the mechanism to wait for the results coming back from the web service. We also do some little error handling here. So, while this does read better than the completion handler solution, cancellation support is still not possible. While it's actually possible to take that task and say .cancel, it doesn't actually do anything. It's just a stub. Oops. So how do we actually go ahead and provide cancellation support? So option number one is your own wrapper. So you could write something that will provide cancellation support yourself. And you can look at this article from TouchLab if you want to quickly grab your phone and take a picture if you really want to write your own wrapper. If you don't want to do that, I do have another option for you. And it's called KMP native coroutines. So while there is no official recommended way from JetBrains on how to do this, the community has provided at least one or two solutions that I know of. So the first solution is KMP native coroutines from Rick Klafas. It's a plugin and library, and it generates a function that's called getLaunchersNative for your suspend function. So if you have a suspend function ABC, it will be getABC native. So we then combine this with the library's async function in a similar way to our previous async await approach to make our operation cancelable. So that let task, you can cancel it and it will actually cancel properly. So the library supports async await and combine, which is sort of a nicer approach to handling it on Swift, and Rx Swift approaches to concurrency as well. But remember the @main actor annotation, or you're going to get a warning. So by now, you should have also heard about flows if you're not already using them in your applications. If you haven't, it's basically just a type of asynchronous operation that can emit multiple values after each other, as opposed to a suspend function that can only return one value. So previously on Android, you had the choice of either using something like live data or RxJava, which both had their sort of issues. And it's now recommended that instead of live data, you start using flows. So this is a little demo app that is an enhancement of the app that we created before in our previous section. So in this example, we're creating a flow and consuming it, and it gets that same list of rocket launch data as before, but instead of just displaying the whole thing big bang, it is going to make it progressive. So first you show 1, then 2 elements, then 3, and it also reverses it so that it's like all the latest rocket launches are always at the top. So let's see how we can actually go ahead and consume this flow on Android and iOS. So the first step to the solution is really to separate out that the consuming of the flow into a new separate view model. And this view model has a state flow property called launches. And we are going to use that SDK.getLaunches, and we're going to use the state in extension function to convert the cold flow to the hot state flow, using that state in extension function within the scope of the view model. But the most important part of the compose code is that you remember and collector state your launches property. And then you obviously have to give it to the lazy column that you're displaying. You have to give it as an item to display that nicely. So in iOS, things definitely become trickier again. This is because Objective-C doesn't actually support generics on protocols. And this means that somehow the interface loses its type on that flow. So we still also need cancellation support and main thread safety as well. So one solution for this, once again, is to use something like Rick Clefas's KMP native coroutines. So here again, we use getLaunches native, and we combine it with the library's async stream. Then we iterate over the stream to assign a value to that published variable all the time. Again, this approach does support cancellation, and remember it's necessary to declare your view model as @main_actor. You can also roll your own little multi-platform challenge wrapper if you really wanted to. But that's it for flows. So dependency injection is next. Who is a fan of dependency injection? Who likes to argue about dependency injection? Nobody? Oh. Okay, so dependency injection is a great way to level up your app for making it more testable, more loosely coupled, but it's also a really great way to start an argument amongst friends. So we're going to be looking at one solution under the flag of DI, but there are others to choose from that are also nice. So the library that I'll be presenting has been a favorite of mine for a long while. Koin is super simple, and now it's multi-platform. But there is some contention in the community whether it uses the service locator pattern or the dependency injection pattern. Today, it doesn't really matter. We're not going to argue about it today. It's Kotlin Conf, yay. So these are the steps that you need to go through to do dependency injection with Koin on Android. So first, you define your modules. You call start Koin at the beginning of your app at app start, and then whenever you need a dependency, you simply inject it. So Koin has an easy-to-use DSL for defining dependency modules. This is the DSL, so we have a module there. And we're defining two dependencies, SpaceX API and SpaceX SDK, where SpaceX SDK depends on the API. But for example, it can add something like client-side caching as well. To initialize Koin to inject dependencies properly, we need to call the start Koin function with all the applications modules. And we can do that by sort of creating this init Koin function that will either pass in the app module or will default to using the variable that we created in the previous part of the step. So next we need to call the start Koin, the init Koin function that we just created from the right part of our application's lifecycle. So for Android, this is pretty easy. As you might have guessed. So you basically just call it directly from the onCreate function in your application class. But for iOS, we have a little problem. This is because you can't actually use Kotlin default arguments in Swift. But there is a workaround, don't worry. So we need to create a bridge or helper function in iOS main that we will use to call init Koin. So on iOS main, we're going to create this init Koin function that will call init Koin, and then iOS app, we can call that function instead. So in iOS app, which is Swift code, we will call that function instead in the init stages of the app's startup time. So when we want to use dependencies, Android is again just a little bit easier. We simply use by-inject. But for iOS, we once again need a bridge or helper function in iOS main. So here we have a class called SDK helper, and it will implement the Koin component interface. It's just a marker interface. We can use by-inject again and then provide little helper functions for all the SDK's functions. And then instead, in iOS app, in the Swift code, instead of using SDK, SpaceX SDK, we are now using the SDK helper wherever we used the SDK before. So in the init part where we actually pass in, sort of inject in the SDK, we're just passing in SDK helper instead. So perhaps you're wondering what other DI options are there. Well, there is Koin from Solomon Braze and Kotlin Inject as well. Of course, we would eventually like to go to production. And if you're an Android or JVM developer, you're probably very familiar with this throwable hierarchy. At the top, we have the throwable class, and it has two sort of subclasses. Error and exception. So errors, like the nasty out-of-memory error, can't be recovered from. But exceptions, like the inconvenient IO exception, can be recovered from if caught and handled properly. But on iOS, this is actually swapped around. While you can recover from errors, you can't recover from exceptions. Thanks, team. So while it's really important, the one thing that's really important to remember is to annotate your shared code with the @throws annotation whenever it's like even remotely possible that you might throw this exception. Otherwise, if you don't annotate and handle your exceptions properly, you're going to get a crash. So throwables are actually, what you need to do with throwables is that throwables have this message. Sometimes it's helpful, sometimes it's not. But you also need to have a stack trace. And we want to take that throwable information, and it usually helps us to debug a crash. So in development, this in iOS, this will actually be a pretty nice stack trace. But in production, they're actually super unhelpful because it's usually just the Kotlin crash, not the actual throwable. So what we need to do instead is log all the fatal errors in Kotlin and attach the stack traces to it. And then we also need the caused by exceptions and their stack traces, but we don't need that final k-abort Kotlin termination log because we know the app crashed. So there is a solution for this, and the community has come together to actually find something and develop it to improve crash reports on iOS. So the first library is NSExceptionKT, and it's going to make sure that you have more helpful reports that make it sensible to understand what actually caused the crash. So it supports different tools like Crashlytics and Bugsnag and Sentry, but I'm not going to show you how they actually work because the implementation actually depends on the crash reporting tool, but the documentation is really good. Another option is CrashKRS from the folks at TouchLab, and it only supports Firebase and Bugsnag, but in the articles and readmes of these two different parties, they actually credit each other for working on the solution together. But if you want to, you also do need some logging in your app. So, and not just to make your crash reports better, you do need some logging. So there is a library called Kermit, which is an open source library from the folks at TouchLab. And in development, you can just log your normal stuff. And it logs to your platform-specific log writers, like Logcat in Android. And in iOS, it will be OS log. But in production, you can actually disable these log statements, and it will also, you can strip them out with the use of a plugin. And it also comes directly with Crash KOS, so you will have nice crash reports as well. Another option for logging is Napier, and it does a really good job at logging to your platform-specific logs that you have during your local development, but it doesn't have all the nice bells and whistles that Kermit has. So a few honorable mentions about some multi-platform magic in the ecosystem. So another way of leveling up your multi-platform skills is learning Compose multi-platform. I hope all of you caught Sebastian and Nikita's talk on the topic yesterday. There will be a recording a little bit later on our YouTube channel. And they covered how you can use Compose on iOS and Android. It's really cool. Something important that I want to show you, and maybe take a screenshot, I'm pretty sure you want to take a screenshot now, is it's a repository on GitHub that shows you the breadth of the Kotlin multi-platform ecosystem, and it's called KMM Awesome. And it's a list of Kotlin multi-platform libraries and tools by my colleague Kostya. So if you're looking for something for your particular use case, give KMM Awesome a try. It's really updated regularly and expertly curated. This is sort of the categories of what's supported. And we're going to zoom into the architecture section quickly. So something I promised to cover in my talk abstract, but decided not to dwell on too much today, is architecture. And the reason for this is either your app is already using a particular architecture, or you have a particular preference already. So KMM Awesome has a long list of libraries that you can use for architectures. So for MVVM, there's Mako MVVM from IceRock, and KMM View Models, again, from Rick Clefas. And for MVI, there's MVI Kotlin and Mobius.kt. So the Java version was originally by Spotify, but there's now somebody else has created the Kotlin version for it. Now, if you'd like to hear about who's using Kotlin multi-platform in production, try the podcast Atom or A Touch of Multi-Platform. So my co-host and I interview interesting folks from interesting companies like Meetup. There were some folks from Cash App about their journey with Kotlin multi-platform. So to sum up, Kotlin multi-platform is now in beta and will be going stable soon. The ecosystem is expanding rapidly to cover all kinds of use cases, and it's ready for you to use in production, and I hope you'll give it a try in your apps. So I want to end off with just a special thank you to all our open source sorcerers and sorceresses for expanding our ecosystem. We couldn't do this without you. Thank you.